Hello, welcome back. So in this video, we're going to see how to create the melting effect for an object. So first we'll create a project. So in order to create the project, we can go to the file and click on this new project. And just we can set the location. So let's say I will create on desktop and create a new folder like melting. So just inside that, just we can select this accept and we can give the name for this project. So like melt effects, and now let it create all this folder so that laterly when we create the catch files and when we export this thing, it will export into the related folders here. So just click on this accept and now click on this save. So like we can save in this project here, melt. And first we'll create the object which you want to melt. So in this case, I'm going to melt the cube. So just I will take a geometry. So inside this, we can create a cube here. So just create a cube. And just I will name it like an melt object. So first we'll convert this into the volume. So in order to do that, just we can take this ISO offset. So select this. And here we can give the number of sample divisions. So in this case, I'm going to give like 300. And now it has been created the volume. So now we need to convert this volume into points. So before that, I will change the position of this box here. So select this and just here I will give the value to like 0.5 so that it will go exactly onto the ground level. So now it has been set onto this grid level here. And next we'll convert into points. So in order to do that, just we'll take an points from volume. So select this and just connect here. And I will enable this thing. So now see it has been converted into points. So now we need to increase the number of points. So in order to do that, just here in the points operation, let's say I will give the value to like 0.02. So it will increase the number of points. And also in this points from volume, here the source type, I will select it to like fog. So now in order to create this melting effect, first we'll take an pop network. So after this, just I will take an pop network. And now we will go inside. So select this. So when we go inside this pop network, we can see this guide. So in case if you want to disable these guides, we can select this node and here you can disable these guides here. So now if you play, nothing will happen. So what the thing is in the pop source network. So in this source first input, we need to select this emission type to all geometry. And now what the thing is, we need to create the collision objects. Now we will going to melt this object by using the other geometry. So I will go back. So here just I will create another cube so that I will use that cube for the melting purpose. Let's I will take this box again. So select this. And what we'll do is just I will enable this template. And now I will use this transform. So transform. Enable this. So just I will scale it down. So I will scale it down to 0.2 or something. Or just like 0.1 in the y-axis, and I will move it in the y direction. So just I will move it. So what I want is just I want to melt this cube based on this animation. Means like I will animate and this cube will be overlapped to this particles here so that according to that it will create the melting effect. So just I will create the random rotation for this cube here. So in order to do that, just I will rotate this in the z-axis. So just I will rotate in the z-axis. Let's say I will rotate in exact like 90 degrees or something. And I will move it in the x-axis here. So just I will move in the x-axis and in the y-axis. Okay. So now what the thing is, we will create the random shape for this cube so that when we make an animation, it will overlap so that it will create the random shape for this particle here. So in order to do that, just we'll take a mountain node. So just we'll take a mountain node for this thing so that we'll get the random shape for this cube here. And also for timing, just I will enable this cube. So now in order to get the random shape, first we need to add the subdivision for this cube here. So just in between, after the transform, I will add a subdivision node. So just I will take a subdivide node and here just I will connect. And I will increase the number of subdivisions. So just I will increase the depth to like 3 or something. Or else like 4, it depends. Okay, now we got this random shape over here. And if you want to make any changes in the mountain, you can you can increase and decrease the amplitude. And also like we can use this element size. So to get more random shape over here. And also we can go to this animation. So if you want to create the random animation for this cube, we can enable this animate noise here. So whenever we click on this play, it will create the random animation for this thing here. So just I will use a template for this thing. So now we will increase the size of this cube here. So just go to this transform and just I will enable this shape. Okay. And also just I will translate towards the Y direction. Okay, that's fine. And also if you want, you can rotate in like Z axis little bit. So just I will rotate in this way. So I will create an animation for this cube over here. So in order to animate, just I will use this transform. So I will go to the first frame and let us animate. So just I will animate this Y axis. So in order to animate, just I will alt left click. And after this, I will go to this 50th frame and also see whenever I move this time slider, it is going to calculate these particles. So what I will do is just I will turn off the simulation so that it will be easy for us. So now we can move this time slider easily here. So just I will go to this 60 frames, let's say. And now I will animate this to the down direction. So after that, just I will animate this here in this way. And again, alt left click so that we know we got this animation. So now what the concept is, whenever it overlaps to these particles, it will start melting here. So we'll get the random melting effect over here. And make sure this cube has to overlap everything. So see, now it has to overlap everything here. And if you want, you can increase the size for this thing. So just we can increase the size. So that's fine. And if you want to completely melt this object, you can test it, like you can overlap all the cube. So you can overlap this entire cube to this particle here so that you will get a total melting effect here. So in this cases, I'm going to melt only half of the particle so that you can see the nice effect of this melting. So just we'll go to the first frame and also I will enable this simulation again. And finally for this, we'll create a null node so that we will use this null node later in this pop network. So select this and just create a null node. And just we'll give the name, let's say like melt source. So next we'll go to this inside pop network. So just I will enable this thing. And I will enable this like template. And now we'll go inside. And here we'll create some of the group over here. And also if you want to align this nodes, you can press Shift S so that we can align it properly. And also like if you press Shift L, it will arrange all the nodes properly. So now we will create an pop group so that in order to create the particles, just I will use this pop group over here and just connect here. And in this, I will create the group name. Let us name it as like M, like melt. So now why we are creating this group, because we will melt these particles by using the object which we have created in this geometry level. So just I will go inside. So in this group, what I will do is just I will go to the bounding and here I will enable the bounding. So what the thing is, we need to melt this particle by using this bounding object. So here we need to browse the object with which you want to create the melting effect. So here, if I select this bounding object and in the swap path, we need to select that null node. So here we need to select this melt source and click on this accept. So now what the thing is, after enabling this bounding object and after selecting this cube over here, so now we will tell that it has to create the particle effect when it overlap onto this cube here. No, at present nothing will happen. So just it will create an overlap. So just it is interacting with the particles, but we are not getting any simulation for these particles. So what the thing is, we need to tell that it has to create the fluid particles when it overlaps. So we need to write a small expression. So for that, we need to take an pop wrangler. So select this pop wrangler and connect here. And here we need to select the group and just we need to select this M here. So just we need to type I@state equals to 1 colon and just we can execute this. So still nothing will happen. So what the thing is, we need to say that now it has to start the simulation when we overlap the cube here. So in order to do that, first we'll take an pop stream node here. So select this, and just we need to connect it to like merge node. And in order to align it properly, we can press Shift L so that all the nodes will align it properly. Shift L. And here we need to write a small code. So just like I group equals to I at the rate state equals to 1. And just we need to execute this. So now what the thing is, whenever the group is going to overlap these particles, means like this stream, so it has to generate the particles. So now we need to create the pop fluid. So select this and we need to create this. So connect here. And here just I will select this. We can give the particle separation as we have given in this pop volume. So I will just copy. So why I'm copying, because whenever I make any changes in this, it will apply inside this fluid over here. So just I will copy this thing. So like if I go back now, so select this, right click, copy parameter and go inside. So select this fluid, right click, paste relative reference, and just save it. Make sure sometimes it will crash the software. And laterally here we have to give some iterations. So let's say I will give the value to like 35 or something. And here the viscosity I will give to 0.03, sorry, 0.3. And also here in the tensile strength, I will give the value to like 5 or something. So once you will see this, so just click on this play. And next after this, just I will press Shift L so that it will align properly. So after creating this pop fluid, so we need to create some force so that it will fall down. So in order to do that, just we'll take an pop force. So select this and connect over here. And now we need to specify the force in which direction you want to create. So at present, I want to go down. So that is like minus y. So just I will give the value to like minus 2 or something. So laterally we can check it after creating the simulation. So according to that, we can give the force. So once we'll see this, so I will click on this play. So still we are not getting any simulation. So what the thing is, just I will stop this and just we'll go to the first frame. And now here, what the thing is, we need to select this force first input and we need to go to this birth and we need to start this simulation. The means like the particle has to activate. So we'll give an animation, simple expression like $FF equals to 1. So just it will create an animation for this thing, like it will activate the particles. And just I will press Shift L. So in case if you want to see the in case if you want to see the particle color, means like temporarily we can create the pop color node. So select this, we can select this pop color node over here. And also after emitting the particles, if you want to create a separate color, we need to add another pop color node. So select this, just I can connect here. So temporarily we'll give any random color for this thing. So select this, just I will give some like blue or something. And for this, we can create any light blue. Okay. And now after that, just will create the collision like ground plane for this thing. So just I will take an merge node. So here I will connect this. So select this and connect here. And I will take an ground plane. So select this ground plane. And also I will select this static solver. So select this static solver and connect here. So just I will connect this thing here and I will connect this to match here. And also what the thing is, just you have to remember the collision object has to be in the left side. So if you select this match and we will drag this static solver to the top so that it will be in the left side. And now we will just go and see, we'll click on this play. And before that, make sure you have to click on this save. So just I will click on this play. So see now whenever it is overlapping, now it has been created some particles over here. Still you can see some of the cube area has been not overlapped to this thing. So it is in the air. So we need to overlap completely. So just I will go to this first frame and just I will stop simulation for time being. So enable this and just will play the animation. So which part is not overlapping? We need to like scale this cube over here. So just I will scale this thing. So we go back, and in this transform, just we can make an uniform scale. So that just we'll see whether it is overlapping or not. So just again, we'll go into the pop network, and I will enable the simulation again. So like enable this, and now we will see this. So now you can see it has been melted properly. And now if you want a better particle simulation for the final file cache, so just I will increase point deformer to 0.01. Before that, make sure you have to click on save. So now we have increased the number of particles. So now we will create the cache for this particle here. So in order to create that, if you go to the pop network and see here in the output, you can select this save to disk here. So defaultly it will create in the project folder which we have created starting of this tutorial. So just select this out and click on this save on disk. So it will take time. It depends on your system performance. So just I will click on this save, and after complete, I will come back. So the file cache has been completed. So now what the thing is, in order to see it properly, first we need to go back. So after going back, so here in the pop network, make sure we need to enable this playback simulation so that it will play properly. So just I will enable this thing. And now we will see this. See, now it has been loaded. So just we'll click on this play. So now we got this simulation. Still, I have interrupted the file cache here. So laterally in the final, I will show the total simulation. So now what the thing is, we need to convert it into mesh here. So just I will stop this, and also make sure you need to save. So like Control S. So now we need to convert the particles into like fluid shape, like a mesh. So in order to do that, first for the pop network, we need to take a node called particle fluid surface. So select this. So now the particles will convert into mesh. So like if I go to the middle of this frame, so just I will click on this play. So see now if I enable this, so see now it has been converted into mesh. But what the thing is, just we need to increase the number of particle separation for this thing. So here I will give like 0.01 or something, so that it will increase the quality of this mesh here. So see, now we got this nice fluid. And for this also, we need to create the file cache. So what I will do is just I will take an file cache node. So select this. And now in order to create a cache, so if I select this file cache, and you need to click on this option called save to disk. So after file cache, I will come back. So click on this save to disk. So now the file cache has been completed. So we will see this. So just we'll go back, and here I will enable this file cache. Before that, make sure just we need to enable this load from disk. So enable this, and now we will see this. So for timing, I will disable this template, and now we'll click on this play. So see, now we got this nice melting effect, and we got nice solid in this cube over here, and still here we didn't overlap the cube over here. So just I will adjust in the final output. So now we got this nice melting effect, and now we need to like give the material for this thing here. So we will render this by using the mantra. We'll give the material. So I will go to the material palette. So material palette. So here like we can give the like aluminum or copper. So just I will give this iron material. So just drag and drop onto this. So now we got this nice material. And if you want to see it properly, we need to create the lights. So just I will go back into the object. And now here we'll create an environment light. So just I will go to the first frame, and in the environment light, I will just browse the HDRI. So here, if you go to this environment map and click on this, so just I will go to the desktop. I have saved this thing. So in the melting, here if I go to this texture, so just I will browse this and click on accept. So we got this nice background. And now we will see how it will look like. Just we'll play a little bit so that we can see the effect properly. So just let it be up to here. And now we'll go to this render view. and we will render this. So just click on this render. So now we got this render. So I will not explain detail about this render thing. So just I will show the final output. So now we can create one ground properly. So just I will close this and go to the scene view. So now we will create an grid node. So just we can take a grid. So select this. And just will increase the size of this grid node. So just I will give the value to like 20 or something. So let it be. And just I will change the camera. And also now if you want to create the camera, so like we can create the camera by using this option, like go to the camera option and camera. And suppose in case if you want to create the camera based on this perspective view, so what I will do is just we can control left click on this camera option, so that now it will create the camera on this thing. And I will lock this camera so that we can adjust it properly. So save this, go to the camera, and now we can adjust it. Up to here. And also we can give some material for this ground, or else we will see. First we'll render this. So now we got this nice setting. So now if you want to decrease the noise for this thing, so just if I go to this mantra settings, what I will do is just I will go to this object mode and go to this option like out. So in the mantra, if you go to this rendering, you can enable and you can increase the number of samples and you can decrease noise level. So just here, I will increase it to like 8 or something, and the maximum sample. So here the render time depends on the value which we'll give. It's like if you increase the number of value, so it will increase the render time. So for time being, I will just give the default settings here. If you want better quality, just you can use this thing. So now if you want to render it like in sequence, we can go to like option this render to disk. Before that, if I go to this image here, you can see there is an like output picture. So in case if you want to save it like an JPG, you can give the extension to JPG. And here, if you come down, everything is fine. And in the rendering tab, you can change the render engine to like physical based render. And also here defaultly it is rendering with the cam. And also here you can see there is a current render frame. So we need to render it from like first to the last. So we need to select this frame range so that you can specify the frame range over here. So in this way we can create this melting effect. So that's it for this tutorial. See you in the next video.